Our first shape that we're going over today is a parallelogram. So like the name implies, the opposite sides have to be parallel. And that's the definition for a parallelogram. Opposite sides are parallel. Then if you measured these sides, you'd find out that PA and LR are congruent and PL and AR are congruent. The opposite sides are congruent. And if you measured your angles, you'd find that angle P and angle R are congruent, and that angle L and angle A are congruent. So that opposite angles are congruent. Now remember that when you have sides that are parallel, you know that you'll have different angles that are congruent or supplementary. Remember that when you have alternate interior angles, they're congruent. And when you have same side interior angles, they are supplementary. Which means they add to equal 180 degrees. And that last one, the same side interior angles being supplementary, is part of our properties. Angle P and angle L would add to equal 180 degrees. Angle L and angle R would add to equal 180 degrees. Angle R and angle A would add to angle 180 degrees. Angle A and angle P would add to equal 180 degrees. So our same side interior angles are supplementary. And then our last property is about our diagonals. And you'd have to draw them in and then measure the two separate parts. And it's that they bisect each other. Now remember that bisect means it cuts in half. So they are literally cutting each other into two congruent parts. So there are no lines of symmetry in a parallelogram because when you fold them anyway, it doesn't line up 100%. So next up, we want to fill in the different angles and lengths. Our first angle that we are looking for is angle BAD. BAD. So this corner, and we can add 89 and 36 together. And when we add 89 and 36 together, we get 125 degrees for that entire angle. And because that angle is 125 degrees, we know this angle down here, angle BCD, is also 125 degrees because opposite angles are congruent. And that is for this whole angle, not just one part of it. And then we need to look for angle ABC. So ABC is this angle. Remember that our same side interior angles are supplementary. So we can subtract that 125 from 180. And when we subtract 125 from 180, we get 55 degrees. And that's the measure for angle ABC. And that's this entire angle is 55 degrees. And that means that this angle down here, angle ADC, is also 55 degrees. So now we are looking for angle 1. Angle 1 is not 55 degrees, but it is part of a triangle that we do know two angles of. So we can take that 124 and 36 and add them together and get 160, and then subtract that 160 from 180 and get 20 degrees for the measure of angle 1. Now I know my alternate interior angles are congruent, so that means that angle 5 is also 20 degrees because angle 5 and angle 1 are alternate interior angles. And I know that angle 1 and angle 2 have to add up to 55 degrees, so I can subtract that 55 minus 20 and get 35 degrees, and that's the measure of angle 2. I also know that angle 2 and angle 6 are also alternate interior angles, so angle 6 is also 35 degrees. Now I know angle BAE is 36 degrees, and it's an alternate interior angle with angle 4. So angle 4 is 36 degrees. And 89 degrees is alternate interior angle with angle 3. So angle 3 is also 89 degrees. Then I know that angle 8 is a vertical angle with 124. So angle 8 is 124 degrees. And then I know that angle 7 and angle 8 are supplementary, meaning they add up to 180 degrees. So I can subtract 180 minus 124 and get angle 7. That's 56 degrees for angle 7. Now we're looking at lengths. So first off, we're looking at DC. And DC is this side, and it's parallel and congruent with AB. So it's 10.8 centimeters. Then I'm looking for BE. BE is here. And BE is part of our diagonal. And remember that diagonals are congruent, or not congruent, diagonals bisect each other. So what's on one side's on the other. So this is 7.7 centimeters. And then we're looking for EC. EC is this length. Again, it's on one side, it's on the other. So it's 4.5 centimeters. And then I'm looking for BC. Where's my B at? B is up here at the corner. So we're going B, hope not in, but on the side. B down to C, which is parallel and congruent with AD, which is 6.4 centimeters. Then we're looking for BD, which is from corner to the opposite side. We've got 7.7 and 7.7. When you add it together, you get 15.4 centimeters. And then last up on this one, we're looking for a deceit, which is all the way across, 4.5 and 4.5 gets us 9 centimeters. Now we are working on a rectangle. Now it also says that all rectangles are parallelograms. So the rectangle inherits all the properties of a parallelogram. So our properties of a parallelogram. First one, opposite sides are parallel. Second up, opposite sides are congruent. Next, opposite angles are congruent. Next one, same side interior angles are supplementary. And last up, diagonals bisect each other. So we still have those same 5 properties because rectangles are parallelograms. So then our other properties, the first one is the definition. What do we know about rectangles? What are measures of the corners? They're all right angles. And that's the definition of a rectangle. It has 4 right angles, and specifically these right angles have to be in the corners. The other one would come in with our diagonals, and if you measured your diagonals, they would be congruent to each other. So our diagonals are congruent for a rectangle. Now diagonals are only congruent for a few shapes, so don't get this confused. Diagonals are congruent for a rectangle. Next up, how many lines of symmetry does a rectangle have? So how many ways can we fold that rectangle so that it would be congruent and matching on all sides? So we can fold it vertically and we can fold it horizontally. So we have 2 lines of symmetry. Now these lines of symmetry will help us on this next part. So again, we have 2 lines of symmetry, one vertically and one horizontally. So remember, in a rectangle, the entire corner equals 90 degrees. So we can find angle 1 by subtracting 24 from 90 degrees. And we get 66 degrees for angle 1. Now we need to use our lines of symmetry. So if we fold vertically, angle 1 matches up with angle 2, so angle 2 is also 66 degrees. And angle 3 matches up with 24, so angle 3 is also 24 degrees. Now let's use this horizontal line of symmetry. So 24 matches up with 7, so 7 is 24 degrees. 66 matches up with angle 6, so angle 6 is also 66 degrees. Angle 2 matches up with 5, so angle 5 is also 66 degrees. And angle 3 matches up with angle 4, so angle 4 is 24 degrees. Now we need to use those triangles that are being made by our diagonals. So for angle 8 is in this triangle. So we have two angles labeled in that triangle already. So to find that missing angle, we can add 24 and 24 together. And that gets us 48, and then subtract from 180. And we get 132 degrees for angle 8. Now we have a line here. And remember that two angles are making that line. So we can subtract that 132 from 180 and get 48 degrees for angle 9. And then we have vertical angles. So angle 10 is also 48 degrees. Now we're dealing with our sides. So RT is this side length, and it matches up with EC because our opposite sides are congruent. So RT is 8 units. Then we're looking for TC. TC is the bottom, and it matches up with the top because our opposite sides are congruent. So TC is 6 units. Now we are looking for RC. RC is our diagonal here. Now notice that that diagonal is cutting our triangle in our rectangle in half and forming a right triangle. And we know the two sides of that right triangle are 8 and 6, so we can find our hypotenuse using what? Pythagorean theorem. So 8 squared plus 6 squared equals x squared. And 64 plus 36 equals x squared. And 64 plus 36 is 100, equaling x squared, and taking the square root, and x equals 10. So RC is 10 units. And then our last one, we are looking for EA. So EA is going from the corner to the center. So remember that ET would be 10, and our diagonals bisect each other. So 10 divided by 2 is 5 units. Now we are going to work on a rhombus. So all rhombi are parallelograms. So a rhombus inherits all the properties of a parallelogram. So remember, the properties of a parallelogram are that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, same side interior angles are supplementary, and diagonals bisect each other. Our other properties of a rhombus first come from the definition, and if you measure all of the sides of this figure, they would be the same. So it has 4 sides that are congruent. That's the definition of a rhombus. Then if you drew in your diagonals, preferably with a ruler, connecting heart O and M to H, and then you measured all of these angles where those 2 diagonals intersect each other, they would be 90 degrees. They would form right angles because those 2 lines are perpendicular. Right diagonals are perpendicular in a rhombus. And that means that the right angles are at the center. Our other property for a rhombus would come from measuring these smaller angles here, where the diagonal cuts the angle, the corner of the larger angle. And you would find that your diagonals bisect your opposite angles. So we already knew that our opposite angles were congruent. So the angle MRH would be congruent to angle HOM. And because the diagonal bisects those 2 angles, you'd have angle HRO, angle ORM, angle MOR, and angle ROH. So this angle, this angle, this angle, and this angle would all be congruent. The same thing would happen on your other set of diagonals. So you'd have another 4 angles that were congruent. Now, how many lines of symmetry does a rhombus have? So remember, it has to completely 100% match when you fold it. And it has 2 lines of symmetry, and the lines of symmetry in a rhombus are the diagonals. So now we're going to use that information. First thing, start with your center where your diagonals intersect each other, because each one of these angles is going to be at 90 degrees because those lines are perpendicular to each other. Then let's use this line of symmetry, which means that that 35 degrees is also angle 1. And then we can use this line of symmetry and find out that angle 5 and angle 4 are also 35 degrees. And then we have 2 angles in this triangle, and we're looking for that third angle. So we can take 90 plus 35, which is 125, and subtract that from 180. Should be, say, 125 subtracted from 180. and we get 55 degrees. And that is angle 7. And then if we use our line of symmetry, it's also angle 6. And if we use our other line of symmetry, then that tells us that angle 2 and angle 3 are also 55 degrees. Next up, we're looking at sides. So first one, HO. HO is a side of this rhombus. And remember, our sides are congruent, so HO is 13 units. And OM is 13 units. And RM is 13 units because those are all sides of this rhombus. We know OB is 12 units because our diagonals cut each other in half. Now we need to look for HB. So we know two sides of this triangle. We know one side is 13, one side is 12. We're looking for that last side. Now, this is a right triangle, so we can use Pythagorean theorem to help us figure out what that side length is. And remember that 13 is your hypotenuse, so it is C. So we have x squared plus 144 equaling 169. Subtracting that 144 from both sides, and x squared equals 25, taking the square root of both sides, and x equals 5. So that's the length of HB, which means that BM is also 5. And 5 plus 5 is 10 units. And now we're going to go over kites. So the definition of a kite is you have two sets of consecutive sides that are congruent. So what I mean by that is that segment KI and segment KE would be congruent. And segment TI and segment TE are congruent. Next up, a kite also has other properties, and we can find those by measuring the angles, specifically angle I and angle E. And if you measured them, they would be congruent. And there's only one set of opposite angles that are congruent. And to help you remember, the set of opposite angles that are congruent are going to be between the sides that are not congruent. Next up, the last two properties are found by drawing in your diagonals. Again, you use a straight edge, connect K to T and I to E. And the first one is if you measured where the diagonals intersect each other, you would find that you had all right angles. So the diagonals are perpendicular to each other. So just like on a rhombus, the first thing you should do, put your right angles where the diagonals intersect each other. The other thing you know about kites is that one diagonal bisects opposite angles. And the diagonal that bisects the opposite angles is also the line of symmetry. So there's only one line of symmetry in this, and in this one it would be KT. So again, remember the line of symmetry, what's on one side has to be on the other. So in our figure here, our line of symmetry would be AC. And again, what's on one side is on the other. So this 45 would be over here. And this length would be 2 centimeters. This 6 centimeters would be over here. And this 20 degrees would be over here. So angle 1 is 20 degrees. DC is 6 centimeters. DE is 2 centimeters. Okay, and remember I said put your right angles at your center. So angle 5 is 90 degrees. We can find angle 2 by adding 90 and 20 and then subtracting from 180. And we get 70 degrees for angle 2. And again, use your line of symmetry. That tells me that angle 3 is also 70 degrees. Sorry, this 5 should be 90. I don't know why I put 50. And then for angle 4, we have 90 degrees and 45 degrees. So we have a 45, 45, 90 triangle here. And again, 45 goes on the other side. So since we have a 45, 45, 90 triangle, we know a lot of information. We know that AE is 2 centimeters. And we know that AB is 2 square root of 2 centimeters. And AD is the same. Then we're looking for, let's do BD first. So we have 2 on the one side, 2 on the other, and 2 plus 2 is 4 centimeters. And then we're looking for EC. So EC is this length, and it is part of a triangle here. Again, it's a right triangle, and we know 2 of those sides. So we can use Pythagorean theorem. So we've got 2 squared plus x squared equaling 6 squared. So 4 plus x squared equals 36. Subtract 4 from both sides. And x squared equals 32. And we can take the square root of that and simplify the radical. And when we divide 32 by 2, we get 16. And 16 is a perfect square. So we'd get 4 square root of 2 centimeters. So next up, we are working on a trapezoid. So definition of a trapezoid is that it's a quadrilateral with a quadrilateral with one set of opposite sides that's parallel. So that means in our figure here, TR and PA are parallel. Again, remember those arrows mean parallel. And because those sides are parallel, we have two sets of same side interior angles that are supplementary. So in this case, if P was 20 degrees, it would mean that angle T was 160 degrees. And if R was 120 degrees, it would mean that angle A was 60 degrees. Now notice that these are not the same supplementary angles because angle TP or segment TP and segment RA are not necessarily congruent in just any kind of trapezoid. Now, when you have an isosceles trapezoid, you do have congruent legs, and that's the definition for an isosceles trapezoid, is that it's in a trapezoid with congruent legs. And you still have a quadrilateral with one set of opposite sides that are parallel, because it is a trapezoid. And you still have your same side interior angles that are supplementary because it's a trapezoid. The other properties you know when you have an isosceles trapezoid, first one can be found by measuring the angles in your trapezoid. So if Z was 40 degrees, that means O would also be 40 degrees. And these are supplementary angles, so that would mean D would have to be 140 degrees and I would have to be 140 degrees. So you have base angles that are congruent, and you have two sets of base angles that are congruent because you have two sets of base angles. And the last property for isosceles trapezoids would be found by, again, drawing in your diagonals and actually using a ruler and connecting Z to I and D to O, and then measuring their lengths. And you would find that their lengths are congruent, so the diagonals are congruent. And then how many lines of symmetry does an isosceles trapezoid have? It has one, and it's the one cutting the bases in half, just like an isosceles triangle has one line of symmetry through the vertex angle. Our next example is just a standard trapezoid. We want to find the other measures. The first one is of angle D. So we'd take 180 minus 120 and get 60 degrees for angle D. And then for angle C, we'd do the same, but with 92. So 180 minus 92. And we get 88 degrees. And then our next example, we are using an isosceles trapezoid. And we have that AE equals 8. So this length is 8 centimeters. And BD, that's the whole diagonal, is 20 centimeters. We want to find the measures of the other angles and lengths. So first off, I am going to put my line of symmetry in here to help us remember that's what's on one side is on the other. So that means that angle 3 would be 30 degrees. And this angle under angle 2 would be 72 degrees. Now we can use that 30 degrees and 30 degrees to help us find angle 6 because we have two angles in that triangle and we can add 30 and 30 together and get 60 and then subtract that from 180 and get 120 degrees. And that is angle 6. And then we have a linear pair here because angle 7 and angle 6 are two angles and they're forming a line together. So we can subtract that 120 from 180 and get 60 degrees. And we know that the angle on top of 6 is 120 degrees because we have vertical angles. We know that the angle to the left of that 60, or to the right of that 60, sorry, is also 60 degrees. 1 because of line of symmetry, 2 because they're vertical angles. Then we can find angle 4 by adding the 72 and the 60 together. And gets us 132 and subtract from 180 because we had two angles in a triangle. We're looking for the third angle. And we get 48 degrees for angle 4. Angle 5, when we flip it over, is also 48 degrees. Okay, that leaves us with angle 1 and angle 2. So remember that these lines are parallel, and we have a transversal here, and alternate interior angles are congruent. So angle 1 and angle 2 are both 30 degrees. Next up, we're looking for BC. BC is the right-hand side. And since this is that isosceles triangle, the two legs are congruent. So that means it is also 14 centimeters. Then we're looking for BE. BE is length from the upper right-hand corner to where the diagonals intersect. And we know that AE is 8, so BE is also 8 centimeters because we know the diagonals are congruent. EC is this length from where the diagonals intersect to the bottom. So let's figure out what AC is first. What is AC? AC is 20 centimeters because we knew that BD was 20 centimeters and our diagonals are congruent, which is why AC is 20 centimeters. So the whole length of AC is 20 centimeters, We know AE is 8 centimeters, so we can subtract 20 minus 8 and get 12 centimeters for EC.